So for composition of functions, we had r of x and p of x, two functions. And it asks us to evaluate r of p of 1 and p of r of 1. So remember, for r of p of 1, we want to find p of 1 first. So that would be r of, well, plugging in 1 here, I get 1 over 1 plus 3, which is 4. So r of 4 would be 8 plus 5, so square root 13. Then here, I'm going to plug 1 in here first and get square root 7. So I have p of square root 7. Well, square root 7 squared is 7, so this is 1/7 plus 3 root 7 if I plug it in for there. Then for b, it says find the y-intercept of p of r of x. Well, find the y-intercept means plug in 0. So if I plug in 0 into r first, I get square root 5. So I want p of square root 5. P of square root 5 is 1/5 plus 3 root 5. So that's the y-intercept of p of r of x. C says explain why r of p of x has no y-intercept. Well, I need to plug 0 into p of x, but I can't do that because I'd be dividing by 0. So 0 is not in the domain of p of x. So I can't find a y-intercept. D says find an expression for p of r of x. So p of r of x, I need to replace all my x's with r of x's. And that's going to be 1 over r of x all squared plus 3 times r of x. So instead of having x's here, I have r of x's. But r of x is square root 2x plus 5. So it's 1 over square root 2x plus 5 all squared plus 3 times square root 2x plus 5. And that is 1 over 2x plus 5 plus 3 times the square root of 2x plus 5. Since when you square a root, you just get the thing. The last question about the domain of r of p of x is probably a little too complicated, so we will skip that. For number 2, we have f of x is equal to 1 over 2x plus 5. And we have g of x is equal to 2x minus 3. And they want us to find where f of g of x is equal to 1/5. So this is slightly different because instead of plugging in a number for x, we are given a y value and asked to find the x value. So we want f to be equal to 1/5. And so what is f? Well, it's 1 over 2x plus 5. We want that to be equal to 1/5. So it's not hard to see that that would need to be x equals 0, because then you'd have 1/5 equals 1/5. But we are not plugging x in. We're plugging g of x in, which means we need 2x minus 3 to equal 0. So 2x equals 3, so x equals 3/2. So we can check it. If I plug 3/2 in here, I get 3 minus 3, which is 0. And if I plug 0 in here, I get 1/5. And so we know that f of g of 3/2 is equal to 1/5. And I've solved the equation. For number 3, there are a bunch of graphs, so you need to look at the graph. But the first thing it asks us to find is r of g of 6. So I need to find g of 6 first. So the green value at an x value, or the green function at an x value of 6. So if I go to 6 on the x-axis and then up, I get 2. So this is r of 2, and r at 2 is about 8.4. Then it asks for p of g of 3. So g of 3 is 0, and so p of 0, purple of 0 is -7. Then I've got r of p of 1. So I find p of 1 first, and p of 1 is, I don't know. It's maybe like negative at least 12 maybe. So let's guess that this is basically r of negative 12. And then when I go to my graph, that doesn't even exist. So this does not exist because r doesn't even exist. The smallest value I can plug into r, the domain of r, is x is greater than or equal to negative 9. So I can't plug in negative 12 into r, so that doesn't exist. And then g of 0, I'm going to plug 0 into g. And I get negative 2, so then I'm going to have g of negative 2. And g of negative 2 is negative 3.4 or something like that. Then it says solve r of g of x equals 8. So I want r to equal 8. So where does r equal 8? So I find 8. R equals 8 when x equals 0. So I need g of x to equal 0. And g of x equals 0 where x equals 3. So x equals 3 is my solution. To check, I can do r of g of 3. That's r of 0, which is 8. So that is the correct solution.